Okay.
I gotta practice a little bit.
1.1 slope and rate of change.
Only it's 1.3. All right, slope and rate of change. This should be an easy lesson for you because it should be something you remember from Algebra 1. I feel like I keep saying that every time we start a lesson. That's actually the next lesson.
What is?
It makes what slope-intercept form of a line, writing the equation.
I remember that.
This is just focused on the slope and rate of change. So we're going to look at rate of change first, which you can use these terms interchangeably. Rate of change we really use more when we're talking about word problem type deals. And we're looking at a set of data and points, we'll use rate of change. So tell me this, if you were finding the rate of change or the slope, how do you do that?
Formula.
What's that formula?
The slope is like y1 over x2.
All right, so you're saying slope is y2 minus y1 over x2 minus x1.
Or it's the other way around.
Or, okay.
I forgot. It might be the other way around.
It can be either way, it doesn't matter. As long as whichever one you start with on the top, you also start with that one on the bottom.
It's the y's on the top, though.
Yes.
Yeah, okay.
Okay, so would you agree with me if I told you that in words, I could say that this is really the change in y, how it changes, divided by the change in x. Would you agree with that?
Yeah.
Good, because that's right. That's why we call it rate of change. And so in our sophisticated mathematical knowledge now that we use all these fancy new things, we are going to condense this from what it is here, and we are going to call this, we're going to use a mathematical Greek symbol. Does anybody know what that's called? Besides a triangle, it's not a triangle. Delta. Delta y divided by delta x. Delta in math signifies change, okay? So delta y is change in y divided by delta x, which is change in x.
I don't understand the point of delta.
It means change. We use no. We use delta to signify change, and you'll see we use lots of, the further in math you get, you'll start using more and more symbols and things to represent various operations and things that you do until you'll be able to write a complete mathematical sentence in symbols and Greek letters and things at some point during your math career. Hopefully, if you go far enough, yeah.
Is that the formula for the rate of change?
Rate of change and slope are synonyms. They're kind of the same. They're synonymous.
Well, there's a lesson.
Okay? So, let's look. This will be, hey, shout out to my husband. This is a chemistry problem. All right, so let me read you this problem. This is straight out of your book. Straight out of Algebra 1. The table shows the temperature of a solution after it has been removed from a heat source.
What page?
All right, so let's say, I'll just write it on here for you so you don't have to. It's a short little table. All right, so the time versus the temperature. The time is in minutes. The temperature is in degrees Celsius. We'll go 0, 2, 5, 8, and 12. The temperature at 0 minutes in was 143.6. 139.4. 133.1. 126.8 and 118.4. So it's definitely doing what? Decreasing, right? The temperature is decreasing as the time increases. So what I know about linear relations is that if that's happening, then my slope should be negative. And since I now know that rate of change and slope are synonymous, then that means that the rate of change should also be negative. So how might I find the rate of change for the solution?
Just plug in some x's and y's.
Does it matter which ones? No. If it's linear, that means that rate of change is constant between all the points. So it doesn't matter which ones that you use. It will all simplify down to the same thing. So I want to do, this time, I'm going to let my time be x, because generally we let the time unit be x, right? That's our independent versus our dependent, which is y. Because independent means you can put whatever you want in for it. Dependent means it depends on what the other one is as to
So which ones are independent?
X is independent and Y is dependent.
So
Y
Y is
depends on the
changing.
value of X. To determine the temperature, it's dependent on how long it's
How
been.
long is
All right, so I'm going to do change in temp divided by change in
So the triangle would literally just be changed.
delta. Yep, it's change. It just means change. That's all it means. So pick two. It doesn't matter which two you use. I think I'll go with the first two as well because I see a 0 in there and that's easy to subtract. So what I'm going to do is, and if you start with 143 here up top, then I'll need to start with 0 in the bottom. You see what I'm saying? So
Wait, on these graphs won't
We've
have
always
like
been
always
talking
been
about, from the back.
I don't know why.
Lopez.
I mean, but that's the formula in the books. The formula in the books is always y2 minus y1 over x2 minus x1. But really, it doesn't matter as long as you start with the same one top and bottom. What was your question?
Won't X like always on the left when it's each other like that?
Most of the time, in scenarios in which they give you information like in a book. But if you're in a real life scenario, you would have to determine what was. But yeah.
What's the dependent, what's the independent?
All right, so the change in temp, 143.6 minus 139.4 divided by the change in time. What do you get up top? 4.2 divided by negative 2 would give you negative 2.1. Interpret what that means.
Basically, it's changing.
It is changing temperature. It is dropping
Negative 2.1, whatever it is.
2.1 degrees Celsius every minute. Does that make sense to everybody? Every minute, my solution is going down. It's cooling off 2.1 degrees. Y'all have done this before, right? Maybe you haven't done delta, maybe you haven't seen it written like that, but you've done slope and rate of change
Yeah.
before. Okay.
Wait, they delta in the book.
Yeah.
Look at this, it's strong.
All right, so carrying on, let's piggyback on the rate of change and the slope and write the equations of lines. And this is super easy too, and this will not take long. So you need two things to write up the equation of a line. What two things do you need? You definitely need a slope. And actually, let's say this. You need, I shouldn't say you only need two things. You can write the equation of a line with a slope and a point, or a slope, and somebody said a y-intercept, that is correct. Or you can write the equation of the line just given 2 points. And so I want to run through all three of those scenarios, writing the equation of the line, and that'll be all I have. So we have some different forms of equations of lines. Do you remember what they are?
No, not really.
No, wait.
Each one kind of goes with,
Like, what,
Kind of.
What do you
Show
say?
us.
okay, that is one of them. Y equals
MX plus B.
mx plus b. What is m? What is
Oh, there's the
b?
point slope.
Y-intercept.
Y minus Y1.
Yes,
equals
that is one.
M.
Do y'all know that one? Have y'all learned?
No,
Have y'all
we
worked?
did do that one.
Okay.
We did do that. I just didn't remember about order.
Point slope. So that's where we do y minus y1. Keep going. How does it go? Slope.
Slope x minus x1.
Okay. That's the, unfortunately,
I
Luke,
didn't like that.
that's the one we will utilize the most because it's the most efficient. X1 and Y1 are just a point on the line, any point at all, okay? And it doesn't matter what it is. And then the last one, which is just a general form, you may not have done as much, is AX plus
We did that
BY
one, yeah.
equals C. And this one is good for finding what? It starts with an I. Intercepts. This one is good for finding intercepts. I always taught my Algebra 1 kids to do cover up to find the intercepts. Did y'all do cover up method to find it? Where you let AX equal C and solve it, and you let BY equal C and solve it, and you find the two intercepts where it crosses the X and the Y axis.
Oh, actually?
Yeah. Maybe you didn't call it cover up. Maybe you called it intercept form. Whatever it is. But those are the three forms of a line. Okay. Most of the time it will be indicated what you want, what form you want your line in. So let's just jump right in. Let's say you are asked to write the equation of a line. Equation in slope-intercept form. What is slope-intercept form?
MX plus B.
Mx plus b. That has the points.
Does that mean we gotta start graphing on this one?
No, you won't really be graphing. You'll be looking at graphs.
Or we're just learning how to write it?
How might I write that equation? What? That's a -4.
We'll have to get the slope.
Get the slope first, right? So to find the slope,
Y2. Oh, that's one.
that's right. If I'm going too fast
do
through
plus
this, tell
two?
me. Yeah. Bless you. So the slope is -1/4, right? I go down 1 and right 4 at every point. You're always going right. You either go down and right or up and right, depending on if it's positive or negative. So if I wasn't told what form the equation of the line needed to be in, I could just plug in point slope form at this point and be done, right?
I'll do that.
All right, so let's see. Remember, point slope is y minus y1 equals m
What's
times.
the point of point slope though?
Well, because if you're given a point and you're given a slope, so you got a slope and a point, it's the easiest form to use.
You're trying to find like another point.
You're just finding the equation of the line. That's all. So y plus 1, everybody sees y is plus 1, minus -1. -1/4 x plus 4. From this equation, I can get to any other form. I can manipulate it to be in standard form or slope-intercept form, right? Huh? What's given to you? Oh, it is. It is. You could use that. I'm going to keep going, though, for a sake of example. But yes, you could just put it in that way with the slope. Sorry.
You just put in MX plus B, just like,
Yeah. So to get it to another form,
just subtract 1.
I'm going to distribute. 1/4 times 4 is 1. And then, yes, just subtract 1. But you're absolutely right, Fatima, that it did give me the slope, the y-intercept.
Wait, do we have to do the point slope first?
No, if you want to plug in mx plus b and solve for b and go through that way, you can. It's a little
So
messier,
Y
but you can do it.
MX plus B is just the point and slope.
Mm-hmm.
And B is.
So if you had looked, what they were saying here is technically this is your y-intercept,
Yeah,
right? So b is -2. So you found your slope and you said mx plus b.
Oh, you don't mind the line.
On that one, no, because it's already given to you. If it didn't give you the intercept to start with. Tell me this. What do you know about parallel lines? Exactly. Same slope. Negative reciprocal slope, which basically means take the slope, flip it, and change the sign. I always call this the flip and switch. We're literally almost done, y'all. Flip and switch.
Flip reciprocal, like,
Negative reciprocal slope. Y'all really will get used to my handwriting soon, I promise. Negative reciprocal slope. Flip and switch.
I was like, flip.
Do this. I won't do a parallel, I'll do a perpendicular. Write an equation of the line that passes through the point 5, negative 6, and is perpendicular to the line y equals negative 3 over 2x plus 7. So, what information can you glean from that?
You already have the slope.
You already have the slope. What is the slope going to be?
Negative 3 over 2.
Close. Positive 2 over 3. Perpendicular.
Oh, the perpendicular.
Yeah. If it said parallel, my slope would be negative 3 over 2, right? So now you need the equation of a line. You've got a point and you've got a slope, and it becomes a problem just like we did before. Plug into point slope form. What don't you get? You don't, it's just easier for me to, I like it better. Write the equation of the line. I didn't tell you what form it had to be in, so theoretically, I could just plug in here and go, okay, I'm done. That's point slope form. It's an acceptable form, okay? Now, if it told you to put it in a particular form, then you could put it in whatever form it told you to put it in. Point slope is just my favorite. It comes in the, you can use, that's what we were talking about up here, is that if you're not comfortable with point slope and you want to come over here and go, okay, well, y equals mx plus b. I know that the slope is 2/3. I'm going to use this point to find b. To me, this is just a lot more work. And then you solve that for b and plug back in. But if that's what you're comfortable doing.
If you have the intercept already given to you.
It is
So if you have the
easier.
intercept
So always, yeah, definitely look at what you're given, and whatever it makes it easier, do that. Does that make sense? Okay.
We don't have to solve.
Turn for you.